This is challenging. I might end up flipping. Okay. So 2.4. Let's see. 2.4 has to do with, I feel like I shouldn't have any dead time because I'm recording myself. Okay, so rates of change and tangent lines. I will, maybe I'll make a video of where this comes from, the definition of derivative, or I'll talk about it in class. But this right here is a derivative, and it's the most important thing in calculus, a derivative. A derivative is another name for a rate of change or a slope or a speed. It's just, it's also tangent. There's many different words that a derivative means, but limits will generate a derivative and they'll define it, and then the whole Calc 1 first semester is all about the derivative. Okay? Techniques in finding derivatives, applications of derivatives. If you look at my Calc BC LEQ up there, are derivatives important in calculus? So I did that with a smile, indicating that, yeah, they're like the most important thing in calculus. Okay, so what is a derivative? And we're going to get much better at them. But for right now, this is the definition of a derivative. It's also called derivative. It's also called the difference quotient. Difference quotient. Okay, so it's the limit as h goes to 0 of f of x plus h minus f of x over h. There it is. Okay, so this will give us the derivative or the slope of anything. Okay, so here's an example. Let's say I want to find slope at x equals 1 of y equals x squared plus x. Okay, so we're going to find the slope at x equals 1. So what does that mean? We've got a parabola, and you've never probably been told that parabolas have slopes. But this one has a slope anywhere. We just, like if I pick that point right there, it has a slope of this right there. That's how steep it is. Right here, the slope is 0. This one has a negative slope right there. So we could find the slope at any point by finding the derivative. Okay, so here's what we do. We use our difference quotient right here. So I should call this f of x. So what is f of x plus h? That's the first thing we have to do. So the limit as h goes to 0 of f of x plus h. So we are taking x plus h and we're putting it into the function for x. So f of x plus h equals x plus h squared plus x plus h. This is our x, and we're making it x plus h. So we're plugging x plus h in for x right there and right there. Now if that's confusing, most people are pretty confused at that point. So if I know f of x equals x squared plus x, what is f of 3? It's 12 because you plug 3 in right there and you plug 3 in right there. 3 squared is 9 plus 3 is 12. Okay, what is f of heart? heart squared plus heart. So we're just taking whatever we're plugging in and we put it in for x. So what's f of broccoli? Owen, what's f of broccoli?
F of broccoli equals broccoli squared plus broccoli.
You got it. Broccoli squared plus broccoli. So what's f of x plus h? It's x plus h squared plus x plus h. Okay, and that's what we got right up here. So,
I have a quick question.
yep.
How can a point have a slope without another point? Like, what is that?
Okay, and that goes into my explanation. So just for the sake of time, I'll make a video explaining that. So that's a really good question that you're thinking of.
Okay, thank you.
Yep. So f of x plus, hey Kevin, x plus h squared plus x plus h minus f of x. So f of x we said is x squared plus x all over h. Okay, so I'm just going to finish this problem and I'll answer questions, and I'll end up maybe doing some more videos with this because it's just trying to figure out how this class is going to go. Okay, so the rest is algebra. You could FOIL that, x squared plus 2hx plus h squared plus x plus h minus x squared minus x over h. And we're finding the limit as h goes to 0. So I'm going to keep cleaning up here. These x squareds are gone. Minus x and a plus x are gone. So I'm left with 2hx plus h squared plus h on top. I can factor out an h. Now I can cross off my h's. I have 2x plus h plus 1. And remember, h is going to 0. So this I can plug that in and just get 0. So my answer is 2x plus 1. Okay, so that's my derivative. My derivative is 2x plus 1. So now let's answer the question. Find the slope at x equals 1. We can plug 1 into our derivative because this will give us my slope anywhere on the graph. Anywhere. If I asked for 1, I plug 1 in, I get 2 times 1 plus 1 gives me 3. The slope is 3. But if I asked, what's the slope at 5? You would plug 5 in right here. 2 times 5 is 10, plus 1 is 11. So if you look on the graph of x squared plus x, and I said at 1, what is the slope at 1? Well, if I can just trace it along here. Right about 1 right there. If you see that if you drew a line tangent to the curve like this, it has a slope of 1. Like tangent means it hits in one spot. So that has a slope of 1. What about at -1? 2 times -1 is -2 plus 1 is -1. So when x is -1, it has a slope of -1. Okay, so we needed another 15 minutes for sure there. So I'll do a video. What's that? Oh, I thought I did. Thanks. I still thought I did.